Welcome to the Math Path. We're going to make a series of more focused and perhaps shorter videos in order to explain certain concepts. This one is going to be a little bit longer because this is kind of multiple concepts all in one that tie together. So, we want to have good ideas, right? Our brains can come up with ideas, and are some of them good and some of them not so good? Well, the crazy thing is, in mathematics land especially, sometimes people would say, it's all arbitrary. There isn't some that are better or worse because something, incompleteness. But in reality, some ideas are better than others. There are well-formed concepts and there are ill-defined concepts. And what's the difference between the two? There are four elements of a well-formed concept. The first element is that you produce an instance of it. You have your idea in your imagination. You want to produce an instance of it, make it real. Make it solid, concretize it like a rock. Make it something that you can show people. Otherwise, if you can't produce an instance of it, you need to consider the possibility that actually it might not exist outside of your own land of imagination, pure imagination. You need to make it. Even Willy Wonka did build the stuff. You have to bring it out into the world, change the world. There's nothing to it. And then everybody can see it, everybody can agree on what it looks like. Second item is, it has to be defined as what it is, not what it isn't. Now, we're going to use the analogy throughout these four items first of an engine, okay? And ultimately we're talking about math too, but this applies to all ideas. So if you had an idea for a new engine, that's great. You need to, how can you prove that it's a good idea? Well, you could build it and make it real. That's the first step. That's the first item of the four that we talked about. And the second one is you have to define it in terms of what it is, not what it's not. Now, with the engine or with other inventions or things like this, these two things could be switched to an extent, because once you have actually built an engine, obviously you, in order to build it, did define it in terms of what it is, or you would have been incapable of physically constructing it. But so the steps could be switched a little bit. You might first define the thing in terms of what it is, and then build it. You also could, so let's say in terms of an engine, you couldn't just say, well, this engine has no spark and uses no gasoline, and that's my engine. Well, there's lots of things that might have no sparks and use no gasoline. But that could be a starting point of your idea. If you're, say, Nikola Tesla, you might say, okay, I'm going to make an electric motor that has no spark. And, people will say skeptically, okay, Nick, good luck. How are you going to do that? And here's why it's impossible. And that's fine. And if you think about it carefully and persevere, and don't pay attention to the people who are inside their box, who are telling you, oh, we know exactly how everything works and why your idea is impossible. Then maybe you will come up eventually with a way that, oh, look, here's how we can do it. We have the magnetic fields timed in such a way that it's going to push the thing around, and look, you don't need a spark. Okay, so the what it isn't can be an initial motive, but at some point you have to get to what it is of, okay, how are you actually going to pull that off? And show us. Why don't you just show me? Okay. And then the third item is it has to not lead to contradictions and paradoxes. Okay. So with the engine, you have to take it and actually turn it on, run it, put it through its paces. Okay. Take it out. Is it gonna work? And this step can take some time. Okay, seeing if your concept has contradictions or not. You might need other people besides you are going to be the ones who find the contradiction. That's very, very possible. It would typically take generations to really know, okay, this new idea really doesn't have any contradictions. With an engine, you have to turn it on, and you may have done something wrong, and the contradiction is going to be the pieces of your engine are crashing into each other. Maybe you made the piston arms a little bit too long, and your piston is crashing into the head of the cylinder. Well, that would be a simple one that you would find very quickly. All you need to do is just rotate the crankshaft around once, and you're going to discover that. And so that's if you're not a very good engine designer, or in our analogy, mathematician. And there's certainly cases of math concepts that all you got to do is look at them for 2 seconds and they're wrong. But if you're a good mathematician, good engine designer, it's going to be something a little more subtle, and you got to take it out. You got to see, okay, what if I run this thing at 7,000 RPMs for 7 days straight? Or what if I put it in a dune buggy and go across the Sahara Desert? We need to stress test it. We need to see, is this really a good design? So that's the fourth thing. It has to not crash, no whammy, no contradictions, not lead to any impossibilities. And then the fourth thing, this is kind of like the black belt of concepts. Concept, at least like an engine, could maybe be, could fail to have this last element and still be okay. But the last element is independence from any contingencies. It's just an independent idea. It's maybe has this element of elegance, of transcendence. It transcends anything, any details. If you had an alien civilization, they might probably think of this same engine. And that, it doesn't have to be the case for everything. If you have an engine, maybe, you take it out from Earth to Mars, and the air pressure is too low, you're not going to be able to adjust your carburetor enough, and then it's not going to work. While that engine was contingent on certain facts of physical reality, as all physical things are, going to be contingent on facts in their reality. But there's some things like, let's say, geometry or things like this that are just eternal, immutable, unchangeable truths. All right, and so that kind of segues into math. So first we went through it as an engine. You have to build it. You build what it is, not what it isn't, obviously. You, no crashes, and it runs, and and it's immortal. It's the elegance it's an immortal, beautiful design, like the Tesla turbine, maybe. So you could remember that different ways. You could say it's actual, it's factual. You actualize it from imagination into something solid and concrete. You base it on the facts about the thing, not what it is not. You have no paradoxes or contradictions, and it's workable and it's immortal. Actual, factual, workable, immortal, okay? Now, what about in math? Let's take the example of the definition of a number. So first you have to bring it into reality, produce an instance of it, okay? What's a number? And in the very first Math Path video, I asked little Rose, what is a number? And she said just 4, which that's a definition by example. She gave an instance of it. Look, here's 4. Here's a number. I mean, kind of. Really, she just said it, 4, so that's technically just sounds coming out of her mouth. But if she had said, okay, here, shown me 4 objects. Okay, look, here's 4 objects. And then pointed to them one at a time, and then maybe held up another 4 discrete objects, such as fingers, showing, look, this is what I'm talking about. I'm talking about how many there are of them, then everybody would understand. There'd be no ambiguity. It'd be very clear. This is what you mean. This is an instant example of a number. And maybe it's not a fully fleshed out definition, but it's you've given an example in the real world. Everybody can understand. The second thing is you have to define it in terms of what it is, not what it isn't. A number, according to our definition, is a magnitude of some kind, the measure of a magnitude, to put it briefly, to put it a little longer, a magnitude measured by another magnitude, because it has to be another magnitude of the same type in order to measure it. And it has to be smaller. And you could say a name given to a magnitude as measured by another magnitude. Anyway, so that's our definition. This definition needs to, third, have no contradictions. So, like I said, some definitions of things crash immediately, like irrational number is a number that's not rational. So, okay, so it's not a ratio. Well, there's a lot of things that aren't ratios. The John Gabriel said, this is all based on his treatise on this subject, of course, it may be a gorilla or a banana under that definition. Those are both irrational numbers, I guess. And it's true. You need a little bit better definition than that. It just immediately crashes because, if that's your definition, I guess you're not a very good mathematician, are you? All you have to do is spin the crankshaft around once and you realize, oh, this engine isn't going anywhere. So then the last item is the immortality, and this is where mathematics really shines, the independence from any details, biological details of human brains, physical details of the world. It just, basically take something in Euclid's elements, such as, okay, the shortest distance from one location to another location is just to go straight to that location. That has to be true in any reality, in any, it's going to be true on Earth, it's going to be true on Mars. You could say, well, that's because Earth and Mars are both connected, actually. They have the same physical laws. Well, okay, if you were God, even, and created a whole separate reality, if you could do that, if that's possible, no connection to our reality, other than, I suppose, God would be the connection. They were both created by God. But in any case, totally unrelated, no sharing, you're still going to have that be true. The shortest distance to get to a location is just to go directly there. that's not, that's not gonna change. That's just a requirement. It has to be the case. Now, going off a little bit on a rant here, there are people who will say, oh no, and it's not just drug users anymore. It's the whole mainstream establishment of physics, of everything. They say, oh no, man, like, what if we're just flatlanders, man? And we might just, our brains just can't comprehend, like, the total, it's mind-blowing, man. What if there were negative 12 dimensions and everything would be, totally different. And you just can't even comprehend, man, but take a hit of this and maybe you can get a little bit. Yeah, okay, that's great. So what exactly is your idea? Can you reify it? Can you give me an instance of it in the real world? Can you make it real and concrete? Can you define it in terms of what it is? No, it's just not what we see here in this realm. It's a different realm. Okay, so it's just defined in terms of what it isn't. And are there any perhaps contradictions or paradoxes in your idea? See, it's very, very trendy, but it's really not cute or not clever to have paradoxes. Very trendy in the modern world, but a paradox just means that you have defined, if the answer to your question is a paradox, it means your question has somehow been incorrectly defined. And that was what these guys like Zeno were clearly trying to say, but something has been lost in translation over the centuries. And here we are, when people are saying, whoa, Zeno, that, I don't know what they think that proves there's no such thing as distance. String theory, whoa. So anyway, if you can't do these four things, you're just talking. You're just talking. Bloviating, to use too big of a word, but you're just talking, and what you're saying does not bear any relation to reality, is not very interesting. This is just an instance of nonsense masquerading as profound mystery. Many such cases, sad. So, if we can stick to actual, factual, workable, and immortal, then we can get out of the cave, okay? We can escape the cave, and if it's not, then it's basically imaginary, okay? Imaginary, nebulous, what's the word that I thought of? It's paradoxical. Well, it's contradictory, and dumb. It's dependent. So it's inked, INCD. Imaginary, nebulous, contradictory, and dependent. If it's real, it's racky, okay? It's real, like a rock. It's as it is, okay? It's defined as it is, not as it's not the lack. And it's consistent, and it's independent, not contingent on anything. So let's rock with Rocky. Let's not get inked with the losers. And that's how we get out of the cave. This is all kind of stuff that sort of is like Plato, what Plato was talking about if Plato had a real job. It's just a little bit more useful and practical but similar ideas than Plato. Bye.